the stereoisomers. I will not discuss in detail because you are going to study in class 12, but little bit you should understand. Stereoisomers. I told you that can be conformational isomers and configurational isomers. See, stereoisomers arises only because of the change in the position of the atoms in the space. Their connectivities are not broken. They just see, take the example of whenever we walk. Whenever we walk, we will find both of our limbs, like hand and the feet, keeps on changing their position. Right? First you put your right leg or left leg. Then again, after that you pull your, if you put your left leg first, then after that you pull your right leg and left leg like that. But when you move your legs, again the legs come into their right place. Okay? Excuse me. Hello. Same thing happens to our eyes also. Sorry. Ears also, eyes also. You can keep on moving your eyeball, the right, left, and continuously you can do. Okay? So that is when the movement of the atoms across a bond takes place. This movement does not give us a permanent change. So in that case, the repeated structure that you get by movement, and again it comes to its original position, these are called the conformational isomers. Say, look at, you will not be able to look at your face, but if you stand in front of a mirror, you'll find the same face you can give different features, sometimes smiling, sometimes crying, sometimes you are gloomy, but ultimately these changes are not permanent. Okay, so these are called the conformational isomers. Say, take the example of this. Say I have taken ethane. Okay. This is ethane. Next moment you find, due to rotation, what will happen? It may happen this hydrogen has come down. When takes place, all right? And that we'll study this conformational isomers. We are going to study after a few days when I'll start alkane. I'll show you the model. Conformational isomers. In conformational isomers, structures are not rigid. But in case of configurational isomers, once the structure changes, it will not come back to our original position. It will be different. Suppose a person, many people, they go for plastic surgery of their appearances. Suppose he or she does not like their appearance, or in that case, suppose if they go for plastic surgery, they get a new appearance, and that appearance cannot be changed to the original one. Okay, so take the example of this. Suppose I have taken this. This is but to in. Okay. Now, in the formation of but to in, it may happen that it may be like this. In this case, you will find these structures normally cannot be changed. See, here both the methyls are on the same side of the double bond, and here in the opposite side of double bond. So there cannot be changed. So these are called the configurational isomers. Okay, in your book they have not given in this way, but anyway, in alkane chapter this word conformational isomer is there. Now, this conformational isomer again is being classified as enantiomers and diastereomers. Same is the case here. Here also you get here enantiomers and diastereomers. This word is missing in your book. Enantiomers also you are going to study in class 12. So this is, I have given you the latest classification which is being done in stereoisomers. But in your book, the thing which is being mentioned, these are very old fashioned. Stereoisomers in your book are being classified into two categories as geometrical isomers and optical isomers. See, whatever the thing that they are given in your book as geometrical isomers and optical isomers, both of them belong to this. They have not mentioned anything about this. But again, in alkane, they have mentioned about this. So it is very, very erratic. Geometrical isomers means what? Geometrical isomers again can be classified into two categories. This is called cis and this is called trans. Cis is this one I have already drawn for you. If the larger groups are on the same side, we call it cis. And if the larger groups are in the opposite side, are called trans. Right. This is the actual one, and this is given in your book, right? So called cis but to E. And this is called trans. Both cis and trans are written in small letter. But to E. But these days, for double bonded system, the Words cis and trans are not being used. Okay. This is called present nomenclature is this. This is also missing in your book. E. But to E. And this is called Z. But to E. This E is being taken from the German word. E means and ENT and gegen. Means opposite. And again, Z is taken from German word zusammen. Means together.
তুমি সব কাজ করো কিন্তু গামলায় যেমন জল ভরা না, গামলাটা একটু এইদিকে সরিয়ে রাখলে বাথরুমের
হ্যাঁ, আমরা সরাইতে ভুলে গেছি কারণ পাইপ দিলে পাইপটা খালি পড়ে যেতেছে এর লিগে আমরা টানি আর কি। Finished? Hello.
Yes, sir.
Yes, sir.
Okay, now my question is that why every day I have to tell you that you have after finishing your writing, then you have to tell me. What is your intention? If you are not intended to study, then you tell me I will not take your class. If you always you feel that someone else will tell, and after writing you will keep quiet. See, if you are not interested to study, I don't mind. Why should I take the trouble? Every day, every now and then I have to tell you we finished. You cannot tell me that's how we have finished. You tell your parent that we are not interested for tuition, then I will not take. This is, I feel it is very, very bad. But from today, many schools have opened. So how many of your school is open? Tell me. Hello.
Sir, ours will open on the 27th.
Which school?
Advanced, sir.
Advanced. Then what about other schools? BSF? Anyone is there from BSF school here?
26, sir.
Huh?
26.
26 January, how your school will open? It's a national holiday.
I mean 25, sir. 25.
Then what about this BK Bajoria?
We don't know, sir.
Then Anthony's?
18th, sir.
Huh?
On the 18th.
18. And yesterday she called me that her school has already opened. What is your name? Please tell me. I think Detinila or something like that. Her school is open and the class is going to start at 8:40. So from Wednesday, I'll take your class at 7:30 instead of 8 o'clock. Though sometimes I get late, it will be 7:30 from Wednesday. And after finishing writing, if you keep quiet, no, then I also will remain quiet. I will not take the classes. As simple as that. And what about army school? When it is starting?
Sir, 18th.
So let me talk a little bit more about the geometrical isomers. These days, or that is containing double bond cis and trans terminologies are not used. Cis and trans concepts are used for saturated molecules. Cis and trans, we are using for saturated molecules, not for this double bonded system. Initially, what it started with, that similar substances are on the same side of double bond are called cis, and if they are on the opposite side of the double bond, we call it trans. This concept is being abolished. But nowhere in your textbook is being mentioned. But in entrance exam, this question comes. This is the strange thing of the CBSE book. So, example, say you have taken 1, 2, dibromo ethane. See, there is no double bond. The molecules with single bond, they undergo very fast rotation. They keep on rotating. I told you, we undergo conformation. But if these groups are very large, it is restricted because two atoms comes nearby each other and hit each other. So in that case, the movement is being restricted. Then they remain far away from each other to avoid any repulsion or collision. So we'll call this to be, as they are opposite to each other, in that case we call it trans. This is trans. Suppose I have taken here say I have gone for this. So this is trans 1, 2 dichloro ethene. But the chlorine atom is smaller than bromine atom because you have already learned in periodic table. If you go down, the group sizes of the atom increases. So this exists in both the structure. So in this case, it can show you both. So the cis and trans structures are these days used in saturated system. Okay. So now let me take this molecule. This is cyclohexane. In cyclohexane, see here, the thick lines means they are above the blackboard and broken lines are behind the blackboard. So now it is this. Means they are on the same side of the plane. If this is in the plane of the board, these two are, both of them are like this. It is there in the same side. All right. So in this case, we'll write cis 1, 2 dimethyl cyclohexane. This I am teaching only for entrance. See now, in this case, if it is like this, if this is the plane, hydrogen is above and methyl is behind the board. In this case, methyl is above the board, white board, and hydrogen is behind. So they are diagonally opposite to each other. So this is called trans 1, 2 dimethyl cyclohexane. So the cis and trans these days are used for saturated molecules, and for unsaturated molecules or having carbon-carbon double bond or any other double bond, we do not use cis and trans these days. Babli. এলি তোমার ফোনটি কেন?
Done, sir.
Okay. Now then in that case, what should you do with a double bond? For unsaturated molecules, it is containing carbon, 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 nitrogen, 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 double bonds. E and Z nomenclatures are used. See, initially these things are being taught in the BSc. This, but in this case, you will find these days you will find in your entrance exam these concepts questions are coming. So if it is not in your textbook, you can't challenge. It is your fault. But these concepts are not difficult. The E and Z nomenclatures are based on the orientation, means placement in the space, of the groups or atoms across a double bond on the basis of priority. The priority is governed by CIP rule. What is CIP rule? C stands for the name of a person, Khan. I stands for Ingold. And P stands for Here we go. The priority of the atoms or groups based on the atomic number of the atoms or groups bonded to the atoms having double. If the preferentially larger priority groups are on the same side of the double bond, then it is called Z isomers. While on the opposite side is called E isomer.
বলে না কিন্তু হাতের তো বলে না কথা কাশিটা বলতো
Done, sir.
Finished?
Yes, sir.
You need not get nervous. It is very easy. See here. Suppose I have taken this. This is very simple one. Earlier used to call it cis. This. Now, according to CIP rule, what we should do? We should see their atomic number. See, atomic number of hydrogen is 1, fluorine is 17. It is having higher priority. As I'll put here 1, then I'll put 2. Okay, here it is 1, and here I'll put 2. So we'll find the higher priority groups are on the same side. Okay, so in that case, what should I call it? I should call it Z isomer. I told you Z has come from the German word called zusammen, means together. So this is our old concept, this is our new concept. So here is 1, 1, 2. So this is the E isomer. Earlier used to call it trans. I am just doing for your entrance exam. If you are not interested, I will not do it. All right. How the earlier concept has let us down. See here. Suppose it is this. In earlier concept, they say that if the similar groups are on the same side, we'll call it cis. In that case, if you go by the earlier concept, then in that case you find that they are on the same side, it should be cis. But according to the CIP rule, it is more precise. See here, atomic number of chlorine is 1, is higher than hydrogen. Between chlorine and bromine, whose atomic number is higher? Whose atomic number is higher?
Bromine.
Bromine. So it will be 1 and it will be 2. So what will be its nomenclature? What should I write?
Trans.
Trans means what alphabet I should use now here?
E. E.
Correct. So if you have developed some confusion, cis and trans is very easy to remember. You know cis is in the same side, trans in the opposite side. So you might develop some confusion that what alphabet I should use. Should I use E or Z? This confusion always occurs. At last moment, sometimes we don't answer it also. So sometimes by confusion, when you write, your answer may be correct, but you always have a doubt. I think I have made a mistake. See here. Just a simple logic, huh? See. Always whatever you know what is cis and trans. You know it is opposite. Higher priority group is opposite, then opposite means trans. Okay. So in that case, when you write it, whatever you see, write the opposite word. See here. It is trans means opposite. Okay? Opposite. What is the opposite of opposite? E. See here. Look, put some vector sign. Look, this is not on the same side. Opposite of opposite is what? Same or not? Look at the direction. Okay, now see, you know, in this case, if I go for the same, if I think opposite of same is what? What is the opposite of same?
Opposite.
Yes. Now let me put a vector sign. What do you get? Do you not get Z? So this is the way to remember. Add some fun in your study, then you'll find things are not boring and easy to remember. Okay, so you know this one. Now see here. If the groups are similar, okay, it's easy for us to do. Now, look here, very interesting. first you have to see the atom which is bonded to this carbon. These hydrogens are directly not bonded to carbon. This carbon is bonded to this carbon. Atomic number of carbon is 6, hydrogen is 1, so it is 1, and this is 2, 1 and 2. Okay? 1 and 2. So in that case, we know this is cis. So what we'll write now here? Z isomer. Now, suppose you have taken this. See, these type of alkenes are very few, where you will find same thing are on the same side. Most of the alkenes are having different groups. So what should I do? If I go by the old concept, 2 methyl on the same side, it should be cis. Then what fault this has done? So let us try to find out by the CIP rule. See here. This carbon, we'll see for priority, we'll see left hand side, priority we'll see right hand side. So between carbon and hydrogen, carbon is having high atomic number, so we'll write 1 here and 2 here. Now look at this. Both of them are carbon. Okay. So what we'll do? We'll try to find a priority by adding their other atomic number to this. See here, this carbon. So I'll write now here 6. Now, this carbon is being bonded to 3 hydrogen. Organic chemistry is not easy. Sorry, not that difficult. Look. See, now there is a tie. This is also 6, this is also 6. So I have to find a difference. So in that case, what should I do? I'll try to add this 3 other atomic number of the 3 other atoms bonded to this. Okay. Well, right now here 1. See, this atomic number of hydrogen is 1, 1, 1. I'll add now 1, 1, 1. Total is what? 9. In this case, see here. This carbon is bonded to 2 hydrogen plus 1 carbon. I'll not add this 3. First, I will see the other atoms were directly bonded to this carbon. This, and this. So how much it comes? It is 40. So this is having higher priority than this. So what will be the geometry here? Higher priority groups are in the opposite side. So what should I write now here? This is the E isomer. This is the way we do it. Huh? Okay. Now say I have taken here this, and this is this. Just try with this. I'll help you. You try by yourself. This you already know. Can you find it? Hello?
Sir,
Hmm? Tell. Hello. So what will be the structure? Isomer? Hmm?
Z, sir.
It is Z. Correct. See here. Carbon is 6. This is also 6. Now 1, 2. 1 plus 1. Here also 1 plus 1. Now you may not know the atomic number of fluorine. Maybe that I know it. For at your stage it is not possible. It is 17 and it is 6. Understood? In that case, this is 1 and this is 2. It is very easy. So this isomer is called the same site. It is the Z isomer. Okay, dear. Now see here. So if I go for this one. So now it is, in this case, this molecule will not show you any geometrical isomer. Why? See, it is here 1, 2. Both of them are 1. So no geometrical isomers. But suppose it is this. See. Have you come across any element with D? Hmm? Hello. Any one of you have come across an element which symbol is D? Huh?
Sir, isotope of hydrogen,
Yeah.
deuterium.
Deuterium. What is his atomic mass?
2.
What is the atomic mass of the deuterium? Huh? Atomic mass
2.
is 1. Is 2. See here now. This is 6. This is 6. This is 1 plus 1 plus 1. This is protium. And this is 2. And this is 6 plus 1 plus 1. So it is what? 9. This is 10. it is going to show geometrical isomers. So it is 1, 2, 1, 2. So this is their isomer. These are the simple. If you, in case of isotope, we do not consider their atomic numbers because isotopes have same atomic number, but their atomic masses are different. Please remember. Okay. So same example I can give you here. Suppose it is this CH3H. See here, they may try to confuse you here. Sorry. No, it's all right. I'll not give more for this. Now, let me go for some example. See now, suppose you have got CH3, then this is H. I'll not go for such difficult example. Say it is NH2 and this is CH3. See here, this is 1, this is 2. Nitrogen atomic number is 7 and carbon is 6. So obviously I will not bother for, because I have to find a difference between them. Until the difference we cannot find, we will not stop. So in this case, you find it is 7 and it is 6. So it is 1 and this is 2. Okay, so this is the Z isomer. So I have taken this. I have to find a difference. Say it is this CH2, CH3, CH2, CH2, CH3. Don't get scared. See here. In this case, this carbon is 6. Is bonded to how many hydrogen? 2 hydrogen. Then bonded to how many carbon? 1. Okay, so it is 6. Here, 6. This 1 plus 1. Then is bonded to this what? This carbon 6. See, sum of both of them are same only. Then when I cannot resolve it, then I have to take into consideration this. So what should I do? I'll write now here 1 plus 1 plus 1. Then I'll take the example of this, help of this 1 plus 1. And it is again bonded to this carbon. I'll write 6. Now I find the difference between them. So what should I write now here? 1 and 2. That you need not add, because looking at this only you know which is bigger. So in that case you will find this is the E isomer. This is the way we find the difference. So at this point in class 11, you may feel this is superfluous or unwanted, but the moment you open your entrance exam questions, you'll find the E and Z are there. But that moment nobody is going to teach you. I have seen many of my students who have already passed class 12, or maybe whom I know, I have some family friend whose children are already studying in Guwahati or in other places. They have taken admission in different coaching institutes. Say, I have taken say this is the molecule. You know what is the name of this one. What is the name of this? This is having higher priority. So it is 1, 2, 3, 4. What is the name of this? The name of this one is 4-hydroxy but then 2En1Al. Okay. Now double bond is there, so I have to find its geometry. So what should I do? I'll write its structure. So what is this? This is aldehyde group. So it is this. I'll write it like this. Okay. I'll do some change here. Okay. So what should I write here? I write it here like this. 4 hydroxy 3. Please change it. 3 methyl but 2En1Al. So I'll write it like this. Look. Now we know what will be this one. This is 1. This is 2. Because carbon is 6, hydrogen is 1. Now between these two, so I'll write here now 6. This is also 6. Now 1 plus 1. And oxygen is 8, atomic number 8 is 1 plus 1 plus 1. So it will be, this will be 1 and this will be 2. So what will be the geometry here? What will be the geometry in this case? They are on the same side. So it will be Z. 4 hydroxy 3 methyl but 2En1Al. Right.
Done, sir.
Okay. So now I change it little bit. Say it is this. This. Okay. Now in this case, what will be the name? No problem. We know it is two ethyl 4, hydroxy 3. I have to write in alphabetical order. Okay, 3 methyl 1 2 3 4 but 2 en 1 al. Now let us try to find out. See here, it is CH H CH CH CH. This side we have no problem. We have because we have already found it. So here still I'll write here 6 plus 1 plus 1 plus 8. Why did I take right? Why did I not take hydrogen? Because these atoms are directly bonded to this carbon. In this case, 6 plus 1 plus 1 is 9. Now between these two, see, this is also 6 and this is also 6. Then what should I do? See here, I'll write here 6 and 6. So for this, I'll take these two, 1 plus 1, and is directly bonded to this carbon. I'll write here 6. So it is 40. In this case, see, this carbon is bonded to the oxygen through a double bond. So each double bond will think it is single bond. So what should I write now here? This, see here, means what? Is equivalent to carbon is bonded to oxygen 2 times. So what should I write now here? It is 6 for this. Then this is 8. Then this is 8. And this is 1. So I'll write now here 6 plus 8 plus 8 plus 1. How much it comes? 20. So it is 1 and this is 2. So this is Z isomer.
দেখা তো আছে তখনও বলতে হাতে বসে
Say you have taken this.
তখনও বলতে আমার কষ্ট হয় একটু বছর নিয়ে দিতে
Say it is this. How to find the priority? See here, bromine is having much higher atomic number than this carbon. It is 1 and this is 2. Now here again the problem is there. So I'll write it like this. See here, C, C, C. You know this one is what? We know this is called, you call it phenyl. Now between these two, what should I do? See here. Carbon, these two, 1 plus 1 plus this carbon. So I'll take this and this. So it is 6. It comes to 14. Then what should I do with this? Low. This is the one which is there. This carbon is bonded to this carbon through a single bond and bonded to this carbon through double bond. So what should I write now here? In this case, I'll write for this carbon 6. For this carbon, single bond 6. For this carbon, double bond. So I have to write it twice. So how much it comes? 24. So it is 6 for this carbon, 6 for this carbon, 6 double bond is there. 24. So this is 1, this is 2. So what is the name of this? See, they are on the opposite side. So I'll write here now E. Then it is number is here 1, 2, 3, 4, 5. Because this is a substitution. 1, 2, 3, 4, 5. So it is, this is 2. So it is, sorry, E, 2 bromo, then 3 phenyl, 3 phenyl, then pent, 2En, 1 all.
দাদা কোথায়? ও কালকে সানডে ছিল। ও
Pent. Now, let me write CH3, NH2, what will be the name of this? Okay, see here. We know priority wise, carboxylic acid is having highest priority than this and this. So these two will be considered as substitutions. So it is 1, 2, 3, 4. So it is 1, 2, 3. So name is what? Alphabetically, see, we know when aldehyde comes as a substitution, either we called it formyl or aldo. All right, if you want to write aldo, you can write aldo, or you can write formyl, you can write formyl. It's up to you. Okay. So let me write here 2 aldo. Sorry, not 4. 4 is here. 2 aldo. Then 3 amino, then 1, 2, 3, 4. So it is but 2 En 1 with acid. Or you need to write 1 also. 2 enoic acid you can write. Okay, now see. We have to find their stereochemistry. So what is this? This is equivalent to what? Is equivalent to O H. See here. What is this? This is equivalent to what? This. Equivalent to what? CO O H. So what will be their priority? 6, 8, 8, 1 atomic number. Nah. So I'll write now here 6 plus 8 plus 8 plus 1. What should I write now here? This is 6, this is 8, this is 8, this is 8, this is 8. So what should I write now here? It is 6 plus 8 plus 8 plus 8. I'll not write this one because it's not directly bonded to carbon. So how much it comes? How much it comes? 30. So priority wise is 1, this is 2. And we know between carbon and nitrogen, nitrogen is having higher atomic number. Then carbon, nitrogen is 7, carbon is 6. This is 1 and 2. So they are on the same side. That is this. This, see, priority wise, aldehyde comes before cyanide. So it is 1, 2, 3, 4, 5. Now, so cyanide will come as a substitution. So what will be the name now here? It will be 2 cyano. Pen 2 En 1 A. Or you can write 2 cyano pen 2 in Al, because aldehyde is always faster. Okay, now see here. Let me see again, write this one. CHO is equivalent to this. And CN is equivalent to C triple bond. So equivalent to what? So it is 6, 8, 8, 1. So I'll write here 6, 8, 8 plus 1. So it is 20. Now this is equivalent to what? Triple bond. This 6, 7, 7, 7. So what will be the sum? 6 plus 7 plus 7 plus 7. 27. So priority wise, this is 1, this is 2. And it is very easy. So carbon is 6, hydrogen is 1. So it is 1 and this is 2. So they are on the opposite side. So if it is opposite side, what should I write? E. Difficult. E and Z isomers. Now we go for optical isomer. Optical isomers we read detail in class 12. The compounds which rotates the plane polarized light or monochromatic light when passed through their solution are called optically active compounds.
Video has gone viral in other news with 4 willing pilots telling us lost his regret whose flight landed in Bengaluru this morning from San Francisco.
Now, what is plane polarized light? You should know. See here. Light travels in all fluid. Because of that, when you switch on the light, your entire room becomes illuminated. When a beam of light is allowed to pass through a nickel NiCOl prism. Nickel, have you seen any prism? Prism you have seen?
Yes, sir.
Most of the prisms are made from glass. Okay, but nickel prism is not made from glass. Made from calcium carbonate. See, calcium carbonate you have seen. Lime, June is white. Dear, If you press calcium carbonate, it becomes colorless. Just like colorless, just like salt. See, salt looks white. You press it, it looks like a piece of glass. Okay? Made from calcium carbonate. This is for entrance exam. So light is allowed to pass through a nickel prism. Then light of only one plane comes out, and that is known as plane polarized I have made a mistake. It will be PLAIN. Please correct it. Okay, I'll show you now. Say, my drawing is very bad, huh? So please don't laugh. This is a source of light. What will happen now? You light it travel in all planes. Now, I want to allow this one to go through. Okay, so I put a barrier and with a small hole. Okay, these are called grid, GRID, grid. Okay. Now, what is a nickel prism? Here I'll put a comma and write. It is a. Okay, I'll put it in some bracket. Sorry. It is a double prism made from calcium carbonate. So how does double prism looks like? Single prism looks like this. This single prism. Double prism into this. So this is nickel prism. What will happen? You will find only one plane of light goes up. One plane. You know, light is an electromagnetic radiation. So electromagnetic radiation, how it will go through? It goes through in the form of waves. So I think this is the one plane it goes. Or you can say it is going like only one wavelength will pass through. Other wavelength will not pass through. See, I think you in your childhood or still you are children only. Have you played with frisbee? Frisbee you have seen, no?
Yes, sir.
See, when you throw frisbee, does it not move in one plane? Huh? So this is the plane polarized light. It moves in one plane. It's called plane. Oh, I'll draw something there. Huh? So I'll write here. Plane polarized or we call it monochromatic The compounds which rotate, flame, polarize light towards right or clockwise are called dextro isomers and are indicated by plus or D. The compounds which rotate the flame, polarize light towards left or anti-clockwise are called levo isomers and are designated as minus or L. Okay, now what will happen? See here. I allow this light to pass through a tube containing the solution. See, the light is supposed to travel and go out straight. But there are some compounds which will rotate it clockwise or anti-clockwise. Say, rotates by plus alpha degree and minus alpha degree. So this is called dextro or dextro. How to designate? D or plus. And these are called levo. How do you designate? We call it L. Oh, will not put inside bracket. Bracket is not there. Or minus. Example, See, this is called lactic acid that you get it in milk. This rotates the light towards right. So we call this one as D or plus lactic acid. Okay, this is L or minus lactic acid. Okay, why do they rotate the light and everything? That I'll tell you in class 12 if you continue with me.
Done.
Okay, then bye.